All right. Hello, my favorite math class. I just have to make sure that all of you know that, and I told Alexa and Wanda this, but I recorded this entire video and then realized that I did not press the record button. So I was not happy earlier today, but here I am now doing the video. And so hopefully this is working. The record button has been pressed. I think I'm fine. Okay, so I am not there, obviously, and I know that all of you are being perfect and well-behaved, and which is wonderful. So we today are going to be starting chapter 2, and at this point you should have already gone through a few slides talking about what chapter 2 is. And so today we're going to be starting on chapter 2, section 1. So in section 1, we are going to be talking about solving equations by adding or subtracting. This is honestly like the basis for the rest of algebra, is solving equations. We'll be doing so much solving of everything, and this part is really just like the beginning of it. And so what we're going to be learning in this chapter, you will continue to see for the rest of algebra. And so it's really important that we definitely like take our time with this, but also we definitely want to make sure that we feel really good about this section before we move forward. So you will get lots of opportunities for practice today, which will be great. And then by the time I come back, I'm sure you'll all be ready to go. Okay, so anyways, we are going to start talking about solving equations. So the biggest thing to remember is that we're, like I said, going to be seeing solving equations a lot. And so when we see this whole thing about solving equations, oh, my pen, not really working, that's better. When we see this whole thing about solving equations, okay, so anytime it asks you to solve something, we always have one goal in mind. Sorry, so our goal whenever we're asked to solve equations, our goal is always to isolate our variable. Now, as far as variables, usually we use x, but sometimes the book likes to get fancy and use different letters. Whatever it is, remember the variable is just our letter that we're using that represents an unknown. So, taking a look at isolate variable, can anyone raise their hand and tell me what isolate means? And since he was so upset that I didn't call on him last time, I would love Bryce to answer this for us. Bryce, what does it mean to isolate something? Great, and I am going to assume that you said the right answer, which means to get something alone or to make it alone, whatever it is, to be alone. So isolate, when we're isolating a variable, what that means is we're going to be get the variable alone. Perfect, okay. So the next question is kind of thinking about what does it mean to get the variable alone and how do we know the variable is alone? So the variable is alone when the variable, and we'll do some double arrows here today, just making things exciting. The variable is alone when it has no coefficient. Now, we know that x on its own does have a coefficient, and who can raise their hand and tell me what the coefficient of just x is? Bryce, tell us what the coefficient of just x is. Yes, it is 1. That's perfect. X is not equal to 1 all the time, but the coefficient is 1 if I just have x. So when I say there's no coefficient, you know what? Let's put that in little quotes. By me saying no, it just means that there's no other number besides 1. Okay, we know the imaginary one's always there. The other thing, the variable is alone when that variable, so variable is alone when it is alone on one side of the equal sign, okay? So again, we know that we've reached our goal when we see that the x does not have a coefficient, which we'll talk more about next time. But basically what we're focusing on today is this piece, that it's alone on one side of the equal sign. So, continuing forward, we're going to talk now about how to isolate. So when we're talking about getting the x alone, we need to figure out actually how we isolate it. So I'm going to switch gears really quickly up here. I just want to show you what these equations are going to look like. So if I have an equation that's x minus 10 equals 4, okay? That's wonderful if you already know the answer, but that's not the point. We're talking about doing the work today and the process. But this is the kind of problem you're going to see. Look at this, see that first of all, x does not have a coefficient. Like, again, we know that there's a 1 there, but it's imaginary. But we also see that x is on this side of the equal sign and it's not alone over there. Okay, so that is our signal, that minus 10 right there. That's our sign that x is not alone and we need to isolate it. And so the next step is, how do we isolate it? So how to isolate. So when we're isolating, sorry, my cough is still acting up. When we're isolating, what we're going to be doing is we are going to undo, or I usually say just the opposite, operations. So when we're talking about undoing or using the opposite operation, if I see addition, who can tell me what the opposite operation of addition is? Bryce, tell us what the opposite operation of addition is. Yes, if I see addition, I'm going to subtract. Good job, Bryce. And then Bryce, how about you also tell us? If I see subtraction, what do you think I'm going to do? What would be my opposite, Bryce? Yes, Bryce, you're going to add. Great job. That is so awesome. Okay, so basically, again, what we're focusing on today is just adding or subtracting, so we're really focusing on doing the opposite operation. The biggest thing that we have to remember today is that when we're dealing with isolating our x, we have to be fair to everyone, okay? We have an equal sign. In this case, we have an equal sign. And there are two sides of the equal sign, okay? We could think of those two sides as like the equal sign's children or something. And even though our parents aren't always like this, we want to be fair to both sides of the equal sign. We want to be fair to both of the children, okay? So if we're going to be fair, what we do to one side, we have to do to the other. So exactly what I said, the biggest thing we need to remember is what we do to one side, we must do to the other, okay? So again, if we are doing anything to one side of the equal sign, we have to be fair, we have to think of everyone, and we need to do everything we're doing to one side also to the other side. So always being fair is the moral of the story. Okay, everyone feeling good? Does anyone have any questions? Not that I can answer them. Okay, so if you do have a question, feel free to pause the video and discuss amongst yourselves. Okay, cool. So, so again, we talked about starting off with this equation. So we have x minus 10 equals 4. So when I'm looking over here at what is keeping the x not alone. Oh, what's keeping the x company? That's so sad. We want it to go away though. Okay, so anyways, the minus 10 or the negative 10 that I see there, that right there, we need to get rid of, okay? Because that is keeping the x from being alone. So if I have the x minus 10 equals 4, there are two ways to organize this, because you know me and my organization, but I prefer one way. It doesn't matter if you do it the other way or not. You get the same answer if you do it correctly, but I do want everyone to see how you do both ways. So if you have x minus 10 equals 4, what I already was able to identify, I need to get rid of the minus 10. So remember that I'm undoing the operation, I'm doing the opposite. So my operation I see right here is subtraction. So Bryce, if I'm subtracting here, if I see subtraction, what does that mean I'm going to do? Yes, I'm going to add. And now what I want to do is I want the negative 10 to go away. And when I say I want it to go away, I want to manipulate this. And what I'm going to do is I want to create a number here that I'm going to add to both sides that gets this negative 10 to equal 0. That sounds confusing, but basically, if I add 10 to this side, that's going to get negative 10 plus 10 gets me 0, and then x is alone. So anyways, saw subtraction, I'm going to add the 10, and remember I need to be fair to all the sides, and so I also need to add 10 to the side. I am working vertically right now, and you'll see I'm making sure I'm lining up all the numbers with each other. I didn't put the plus 10 under the x, okay? I put it underneath the numbers. And remember, I'm adding 10 just to both sides, okay? Both sides of the equal sign. I'm not adding 10 to the x. I'm just adding 10 to this general side and adding 10 to the side. So anyways, if I add down, so if I think about like stacking numbers and adding down, I still have my x. I did negative 10 plus 10, which gets me 0. And we're just going to write 0 for now, equals 14. Now, I should not be writing zeros. There's no point. So basically what that ends up being is just x equals 14. Now, if I were to write this a different way, which might work for some of you, which is totally fine, if I have the x minus 10 equals 4, we know that I want to do the opposite operation, which is add, and so I'm going to add 10. If you want to line this up, horizontally, I can do x minus 10 plus 10, so all on the same line, equals 4 plus 10. Sometimes people think this is easier because then you can see the minus 10 plus 10, and you know that that's going to get you 0. So you have x plus 0 equals 14. Same thing, x equals 14. Okay? Wonderful. Great. So let's move on to the next one, and we'll have some people help us solve this problem. So our second problem is going to be x plus 7 equals 9. So, who would like to raise their hand and tell us our first step? Bryce, yes. How about you tell us our first step? Oh, so you notice we have addition. Good. So if you see addition, you're going to subtract 7. Good job. And remember, I need to be fair to both sides of the equal sign, both children. And I'm going to subtract 7 over here. So Bryce, how about you tell us what would happen next? I'm going to assume that you're done explaining or that you're explaining it correctly. So I have my x plus 7 minus 7 gets me 0. And eventually you do not need to write this step. We're just doing this for now. 9 minus 7 gets me 2. So I get x equal to 2. Okay. And if you are doing it the horizontal way, that's totally fine too. But of course, you should be getting the same answer. Any questions? Okay, cool. So we are going to go ahead and flip the page over. And I promise I'll call on other people besides Bryce. I'm just hoping that Bryce is not upset anymore. So let's move on to the next one. So last concept that we want to go over today is you are going to see some problems that tell you to check your answer. Now, if it says to check your answer, that does not just mean you going into the answer key and literally checking your answer that way. This actually means algebraically checking your answer. Checking your answer involves work. If you do not show that work, I will not give you credit. So when it asks to check your answer, this is at the end of the problem. So you've just solved for x. The first thing that you're going to do is you plug the answer that you've gotten. So you plug the answer into the original problem. Ooh, that's not how you spell problem. No, I don't make mistakes. They're just happy accidents, exactly. So plug the answer into the original problem. And remember that when we're plugging something in, that means that we're going to replace x, okay? So whatever problem or whatever you got for x, wherever you see an x, you are replacing it. But remember, we're using parentheses and making sure that we're fully replacing the x. Once you replace it, you'll go ahead and solve and such. And basically, you're going to look for if both sides are equal, your answer is correct. Okay. Yay. All right. So let's just look at an example of this. So I'm going to give everyone a moment to make sure you have all this down, even though I'm not there, so I don't really know. But I'm going to assume we're all good. Okay, cool. So let's move on to example 3. So if I have negative 5 equals k plus 5, okay? So I need to solve. My goal is always to get my variable alone. And when I look over here, I see my variable is not alone. I have this plus 5 over there. So, and we'll do someone besides Bryce, who would like to raise their hand and tell us what I'm going to go ahead and do to both sides here so that I can get my k to be alone. I'm going to pretend like Eva's raising her hand. Eva, go ahead. Tell us what we would do. And I'm going to pretend like you did that correctly, which I'm sure you did. And so you said, yes, I see addition. So that means I'm going to subtract 5. And I need to be fair to both sides of the equal sign. And I need to subtract 5 from both sides. So how about, who would like to talk us through our next step? Tyler, so quiet over there. How about you share with us what you would do next? I'm going to assume, of course, that you explained that right. So yes, I have negative 5 minus 5. So this is actually where people get very confused and will automatically think this is 0. This is where our addition subtraction comes back. So negative 5 minus 5 is going to get me down to negative 10 equals, I have the k. And then negative 5 plus 5 gets me 0. So I'm left with negative 10 equals k. Now, sorry, sometimes, personally, just because I'm, a little crazy, I get annoyed when the variable doesn't come first. Does it matter? No. But sometimes I just like to write this instead as k equals negative 10, just so that the k is in front. You do you, same answer. Great, so anyways, we solved this, and so here's the part that's going to be a little different, is now you're going to need to check your work. So again, this will be a whole part of the problem where you need to show your work that you've checked. So I take the original problem, so negative 5 equals k plus 5. And my first step told me to plug the answer that I got into the original problem. So my equation, I saw I have a k, and I'm going to replace the k with the answer I got. So negative 5 equals, I'm going to use my parentheses, negative 10 plus 5. Okay. So next step, in my parentheses, there's nothing else I can do there. So I'm just going to rewrite that without the parentheses. And I'm going to get negative 5 equals, I have negative 10 plus 5. So I'm at negative 10. I'm going 5 up the number line, which is going to get me negative 5. Is negative 5 equal to negative 5? Yes, I can give myself a little check mark, give myself a little star, whatever you want to do to make yourself feel special. And that is what would tell you that you've checked your answer and that your answer is correct. If you did this and you got two numbers that are not equal to each other, that means that something is wrong. Okay, so checking your work is like the easiest way to know if you got a problem right, as long as all your math is being done correctly there. All right, we're going to do one more problem. So, oh wait, anyone have questions? And if you're raising your hand, I'm going to hope someone else can answer the question for me. So, great. Okay. The last one is, let's go. X plus 6 equals 6. Who can raise their hand and tell me what I should do first? Julie, yes. How about you tell us what I would do first? Yes, Julie, exactly. So I see plus 6. I see addition. That means I'm going to subtract 6. And I have to be fair to both siblings, so I need to subtract 6 from both sides. And what is going to happen next? How about Bryce? No, just kidding. I've already called him Bryce enough. Hopefully Bryce isn't sad anymore. How about, who else is in my class? Oh, Sam. Sam, how about you tell us? Yes, great. And so I see a 0 here, which we don't need. But I have x equals 0. Is that okay? Yes. So I'm going to take a moment. I'm going to turn over here. As a little reminder here, it is okay to get 0 as an answer. Okay? There's nothing wrong with that. Your variable can definitely be equal to 0. It is absolutely possible, and it will happen a lot, in fact. So do not get disturbed if you see 0 as your answer. That is possible. Okay, so anyways, I get x equals 0. Great. Let's check our work. And I'm going to give everyone a moment right now on your own to check your work, or to check this on your own. You can pause this video while you're checking and then restart it when you're all done checking. Okay, so I'm going to assume that everyone has sat there and checked your work. So, like I'm sure you all did, we had my original equation, x plus 6 equals 6. I replaced my x with the answer that I got. Nothing else can go on in here, so I'm just going to have 0 plus 6 equals 6. 0 plus 6 is 6. Does 6 equal 6? Yes. Give myself a check, a star, whatever it is that you want to do. And that is that. So that is actually it for our time. And so you all have a problem set to work on practicing these problems. And when you are done with your classwork, if you have time, you'll do some presentations on the work that you're doing. So yeah, can't wait. Miss you all so much, sort of. And I'll see you all on Tuesday/Monday. Okay, bye.